And the book, this is the organization. So it has different kind of parts. We have part 1, part 2, and part 3. And we can see the part 1 is basically the core Pytorch, where you learn a lot about the Pytorch. And this is one of the most important thing I think for us in the book, because we are basically trying to learn the basics of Pytorch and now move to a niche that actually apply to us, that is NLP. So we can go and do like other books for deep learning with NLP, like maybe Hugging-Face book, NLP with transformers, or that's any book we can discuss this. So I think this is the most important, because all those deep learning book, NLP, they use Pytorch, but also we have other the real life part where we have the part 2, which is learning from image in the real world, where they do some kind of end-to-end projects using image. But also the last part, which is basically about the deployment, which I think we for now, I think I don't know if we will go through that, but I think the basic idea is for us to get some sense that we can quickly move into the niche for NLP. So I'm not sure. What do you think, guys? Because do you think we can move into even chapter part 2, part 3, or we can just get the basic of from part 1 to part 1 and move and get another book for NLP with deep learning? What do you think?
I think for now it's okay to just start head on, then see what happens.
Okay. Yeah. Right. Cool. Okay. So Tunde is okay with chapter 4. Chapter 4 is real world data representation using Tensor. Right. So okay, go. So if nobody is also presenting chapter 5, I can do that. So I mean, yeah, we can do all that. So let's get going. I'm the one that present chapter 1. So these are basically the objectives of chapter 1. How deep learning basically changes our approaches to machine learning. As we know, previously we used machine learning in those days where we have the deep learning also existed, but there was some issue, what they call where the deep learning ceased to flourish due to some many problems, like there is no optimization algorithm that can propagation. There is no resources to do that, and the deep learning was not that deep, well, more than many layers. So actually it doesn't shine well in those days. And one of the objectives, also the idea, is to understand why Pytorch is a good fit for deep learning and examine deep learning typical projects. So, and also the hardware. So basically the chapter tries to undergo these 4 objectives, and we'll see each one of them. Also, the book focuses on practical Pytorch with aim to cover enough ground to allow you to solve real. So the book, as I said, if you look at from chapter 5, basically touches about images. But it does not actually go into like text or NLP. I presume the authors of the book are actually deep learning practitioners in maybe image and stuff like that. They are not NLP people. So when they cover the first part, which is basically about the machine learning, about the basic of the Pytorch, they now move and do the project related to image and stuff like that. So yeah, so we see that. So, and basically the prerequisite of this book is experience with Python, which I believe we all have, like classes, all this kind of stuff, and willingness to learn. So that is basically the prerequisites of the book, and I believe we will have that. So let's move on to the first objective: how deep learning changes our machine learning. So deep learning and machine learning. So one of the basic thing we all know is in machine learning we do feature engineering, right? Given, for example, if you want to do sentiment analysis, you need to try to create features from your text or tweet, maybe back upward, or embeddings, or all those form of features representations. You need to engineer them yourself so that you can have that, right? But in deep learning, it comes all the way to change this way we do machine learning. It allows us to automatically create our features, but without the intervention of human. So it eliminate one step between machine learning and deep learning. In deep learning, we don't need to engineer our features, but in some ways, and sometimes we inject these features as a prior knowledge with the learning system. For example, somebody can do sentiment analysis with deep learning, but you can use lexicon to inject the lexicons into the system so that it can have some. So we do have some sense of that. So this is basically one of the basic idea of how different this paradigm works. So this is machine learning. If you look at this is our data, and these are some of the features, maybe bug of board and stuff like that, handcrafted. You create the features and now you impute them into the machine learning algorithm, and now the machine learning algorithm do classification. For example, given digit, it gives you its 44 number, right? So here we have somebody just engineer the future, but this is deep learning, right? You just give it the data, and now this is a deep learning system. So if you look at this one, deep learning system, there is no data engineer, right? So you can look at it, it's something that we just put. One of them here, maybe it's a batch of data, and you can see here there is a arrow going down, right? So this means that we are learning something from the first step, because you can see this is the point the data comes in, and it's moving down, or it's moving down here. It means you are learning different representation, right? You are learning different representation, and from you can see from the top, you just learn some kind of a line, and different. So up to the end, you learn the correct presentation. So this the last step, you can see a representation. This is a representation. So you can do the classification. So this is basically the difference between deep learning and machine learning, how they are. And if you look at this is how they do the learning the features. If you look at this, as I said, this is learning feature. Somebody's learning feature. This is how the features works. So for example, here you are given images, and you want to do classification of some images. So what we have many layers. This is one hidden layer, second hidden layer, third hidden layer. We have the output, the input. So the first hidden layer will virtually learn some part of the pictures, right? So if you look at this one here, we learn some stuff here. So this is the same thing. So this layer 1, learn this one. The second layer will learn some stuff from the picture, trying to put them together. You can see we start learning the nose, we can start learning the eye, we start learning the ear, you can see that. And the third layer actually learns the maybe the correct. So this is what we call layered learning. Yeah. So deep learning is just nothing but mathematical representation that automatically learns some mathematical functions that learns from given input to give some output. That is basically what machine learning. So all these stuff you can see in this layer, they are basically mathematical functions. So all these are mathematical. So basically deep learning is just a mathematical functions that try to automatically learn some features given some input. So that's what deep learning is. And yeah, so that's about the machine learning and deep learning, how deep learning revolutionized machine learning, and now people are moving to deep learning, especially in NLP. The traditional machine learning the works, but now people are moving to deep learning stuff. All right, so that's the first session. So the first part, if anyone wants to add something, feel free to unmute and talk. Yeah, as I said, this is just like a group discussion where we discuss. Yeah, so if you have anything you want to input, yeah, feel free. Okay, so it means no anything. All right, so let's move on. Okay. Yes, Idris.
Yes, I think there is one point that deep learning basically means how deep the network is. So how many layers you have determines how deep the learning is. So
yeah. So yeah, it is. Yeah. So we have what we call So why is called deep, right? So all machine learning, these are called shallow learning. They are shallow learning. What does that mean? So if you look at this deep learning, this is called layer representation, and the way it is called deep because we can have multiple layers here, and the more layers we have, in some ways, the more the more fine-grained representation it will learn, right? So we have deep neural network with many layers that they learn. So the more layers I think you have, the more better representation. So this is just like just an example on how this work, right? So what about if some oh god, let me put also my computer charger. So if we look at this one here, somebody will say, why can't we put the machine learning also in this kind of layered representation? So one clear difference between machine learning and deep learning, deep learning, the representation is layered. What I mean by layered is that the layer one, what you learn is different from what. So it's layered representation. So if you can concatenate this machine learning algorithm, they are not lying in layered representation. So we have some form of, one may say, what do you call them? Gradient. What do you call bagging? Those kind of machine learning that we put, you call bagging, right? Yeah, like SGBOS, where you can take the output or one machine learning output or one score and try to, yeah. So but that is not actually the idea of layered representation. So the more layer here, deep, how deep learning is called. Yeah, it's called deep learning. So yeah, anyone want to add something? Tunde, Ibrahim, Halalu. Okay.
Well,
yeah.
I just have a question. So my question is, how deep can we go?
Right. So Falalu is saying, how deep can we go? Well, I'm not sure how deep we can.
If I may chip in something here. So the depthness is determined by your requirements. It's determined by the task you have at hand. Sometimes you can go very deep. That is that the layers become, or you can go very shallow that you need more layers. So usually this is determined by extensive experiment to determine how deep you can go, so that you don't go shallow and you don't go very deep that you don't need the extra layers. So it's just experiments usually.
Right.
That when we talk about GPT-3, we can have billions of learnable parameters, and the number of parameters is determined by the number of layers.
Somebody who is speaking like Idris, who is speaking like oh okay. Falalu, are you talking?
Yes, I was saying when we talk about when we talk on GPT-3, you can see that there are billions of parameters, learnable parameters.
Yes.
And these learnable parameters are determined by the number of data and the number of stacks of layers we have. So that's why I was asking the question.
Okay, yeah. So as Idris is saying, like the number of layers determined by the application. But if we look at this deep neural pre-trained model like BARD and GPT, are saying they have large number of layers, right? I mean, but they can work pretty well on many applications. That means they are also domain dependent. I don't know, Idris, what do you think? Because these large models, they have, of course, we know large number of layers.
So I think I don't know specifically what inform the choice. Maybe I will have to read the papers, but since they are generic, I think the design took care of most of what maybe will be applicable using those pre-trained models. So and most of it, I think I attend one of the presentation on the MT Mondays, And what they were saying was I couldn't find it. So maybe yeah, I will
Okay, yeah.
Yeah, I will inform the group when I find
Yeah.
the specific point.
Okay, yeah, so we can read more. Yeah, so let's move on. So the next thing, so now we understand why the deep learning and machine learning, how they differ and what deep learning is. So the next thing, let's move on to deep learning steps. So the book basically discuss about this kind of steps that one way, the first thing we need to ingest whatever data we have at hand to machine learning. So you can see here we have the data. We need to find a way to inject this data to this machine deep learning model, right? And we must somehow need to define the deep learning machine. So this is what kind of machine are we going to use for deep learning, right? So this is one thing that the book says. Number one, find how ways to inject your data into the deep learning machine. Number three is we must have an automated way of training to obtain useful representation. So we must have automated way. For example, now this is the deep learning machine. Now it produces some output. Now this output, if it's not near to the initial input, so we must find an automated way in which we can train better, that we can back propagate, trying to adjust our way to trying to train better and get a better representation. So this is one good representation of how these guys work. So this is actually in deep learning. This is the structure how deep learning works. So you have your input. This is from the book Data Deep Learning with Python. This picture, you have your input, right? And you have this your layered transformation. So look at this. This is your input. This is transformation. You have many transformation which are layered, right? These are the layered. Can you see that layer representation? So you can have many representation here, layer representation, and you can have the prediction. So for example, now I input a number 4-digit number, single 4, and now I did the transformation, stuff like that, and now I make a prediction to have Y, right? And now what deep learning models does is, okay, this is a prediction, and now the target, the true target is Y. This is a prediction, Y, right? Then deep learning provide what is called loss function. So the loss function will try to find whether this guy, the prediction and target, are they the same? What is the difference? How far they are? And now this loss function will calculate what is called loss score. So the loss score is what determine or tell us how good our system is. So if the loss score, the lower the loss score is, the better. If the loss score is 0, it means we have the perfect prediction, right? Yeah, our perfect system, I think, yeah. So, but if loss score is large, for example, we predict the actual target is 3 and the prediction is 4, the loss score maybe like 0.5 or something like that. Now it means the loss score is very high. We need to update our weights. So these are the layers. We input what are called weights into our layers. So these weights are randomly initialized. Of course, they are nothing. Of course, your first maybe prediction may be nonsense, may not be actually near to this one, because these weights are random. So you just random some parameters. These are called learnable parameters, and maybe learner rate, you give them. So now when you calculate the loss score, which is basically maybe high, you need to update your weight, the parameters. Now, how can you update the parameters? We have what we call optimizer, which implement what we call back propagation, and it is the one that actually determine how we can change our weights and also how far we can go using what you call learner rate. So you update your weight. For example, now at the beginning, you look at your weight is 2, you use your weight random 2 or 3, and now you do transformation and you find the loss score is very high, maybe, right? So you need to update your weight, and now you need to go back. And now how can you update your weight? Now one way is to change your parameters, and also through what we call back propagation gradient descent. And how can you move, in which direction? You need to move opposite the direction of your gradient to update the yeah. So this is basically, we will discuss, I think, along the chapter, the details of it, but this is, I think, the skeletal structure on how deep learning works. Yeah. So training consists of deriving the criterion toward the lower, modifying. Yeah, so this is basically the deep learning structure. Yeah, so anyone want to add something here before we move on? Anyone want to add something? Tunde, do you want to add something?
No, so far everything is clear.
Okay, right. Anyone so confused or want to ask question? Anyone with question or want to add? Feel free. We said this is just group discussion. It's not teaching. So yeah, we just discuss and learn. So if I do not explain something clearly or not that, then somebody can complement and we can build the understanding. You know, yeah. And of course, if you don't understand, also you can ask. Okay, it means nobody want to add something, right? So let's move on. So now we understand this. So let's look at Pytorch for deep learning. So Pytorch is basically the library for Python programs that participate building of deep neural network. More or less where we have sklearn, where we use machine learning, then we have Pytorch. As Pytorch does programming, Pytorch provide an excellent introduction to deep learning. So as you know, Python is one of the Go, right, for programming. Then nowadays, Pytorch provide that excellent introduction. But somebody can say, no, maybe Keras provide that, right? So see that, yeah, of course, Keras is really intuitive and, you know, the one way to get into deep learning, but we are not, we want to go into research in some ways, and Pytorch is the goal for research now. And we can see at its code, it is the deep learning machine in Pika rather than complex. Okay, so at its core, the deep learning machine in Pika above is rather complex mathematical function. So you can see here, all these one are mathematical functions. They are just mathematical functions. Now, Pytorch is the one implement all these mathematical functions, and you know, Pytorch has this loss function. Pytorch has optimizers. Pytorch, you know, all these mathematical functions, Pytorch implement them. So you don't need to do them manually. You know, in those days, people do implement these mathematical functions by hand using programming, but now Pytorch implement this. So at its core, deep learning, the deep learning machine in figure above is rather complex mathematical function mapping input to an output. To facilitate expressions, this function Pytorch provide a core data structure tensor. So you see, Pytorch provide what is called core data structure tensor, which is maybe generalized arrays. Yeah. So Pytorch provide core data structure that can be used to implement all those functions, which is called tensor. Then Pytorch come with feature to perform accelerated machine operation. So another thing is Python comes with features, because one thing it comes with tensors. Number two, it comes with accelerated machine. So you can run all these mathematical functions using GPU. In addition to, of course, you can run on CPU, but if you want to fast actually performance, you can do run with GPU. So Python comes with this stuff. Yeah. So why Pytorch? So as I said, we have many other framework to do that, and the book discusses this why Pytorch. So it is Pythonic and easy to learn. So what do we mean by Pythonic? So if you can write programs in Python, then you can find Pytorch so intuitive, like just you're using Python. It will also give us tensor, as I made mention, which is basically generalization of matrix or array. But Python offers two important things. The book says, number one, it provides accelerated GPU, which speed us our performance. So if you want to work for deep learning, you can run on CPU, but when using GPU, you can actually have accelerated computation, maybe 50% speed than using CPU. So that's one thing Pytorch provides us. Pytorch provides us the support for numerical optimization. So as I said, all these mathematical functions that we can see, optimizers such as Adams and whatsoever, this layered and this stuff and the loss function, everything Pytorch provides us. So Pytorch provides us all this stuff, and so these are the important things that Pytorch provides us. One thing is the GPU support, and also the optimization optimizers, and yeah. So this is one thing we should know. While Python is not solely built on C Python, but a lot of code from Python, they are not Python. A lot of code in Python, they are not Python. They are from C++ and CUDA. Yeah. So it has also been other language interface for deep learning. Okay, yeah. So we will see one thing with Pytorch in the next couple. Yeah. So anyone want to add something here on Pytorch session? Okay, so I need to move on. If no addition, no question. Okay, so the deep learning landscape. So one may choose, okay, I want to do deep learning, right? But where can I start? What framework should I use? There are a bunch of them, right? Someone may be confusing. So you can see we have TensorFlow, Keras, Pytorch, Theano, Caffe, Lassa. You know, all these are deep learning framework, right? So which one should I use to use? So that's a good question. But TensorFlow was the go for deep learning framework. It has come before Pytorch, and it is one of the widely used framework. So you can see Theano and TensorFlow were the premier low-level libraries working with a model, you know, to define what is called computational graph. So Theano and TensorFlow, they define what is called computational graph. So for them to do deep learning, you need to build graph and now back propagate on that. After you build in the graph, then you can do so. Keras, TensorFlow and Theano, they are based on what is called computational graph. Lasani and Keras were high-level wrappers around Theano, and with Keras wrapping TensorFlow. So this Lasani and Keras, they are high-level API of Theano, but Keras is also a high-level wrapper around TensorFlow and Scenic. In fact, right now, Keras become the first class API for TensorFlow, right? So Keras now has been consumed in TensorFlow, becomes the first class. Caffe, Dynet, Torch, and MSNet have various niche. So you can see this is basically the different classes we have, but this has been now with rapid development of deep learning. All this now they have merged into machine learning. Deep learning has now merged into two things: Pytorch and TensorFlow. So all this one now, some of them has been, for example, TensorFlow consume Keras, right? Pytorch consume other stuff, right? So let's look at this. Now, if you want to do deep learning, you can do deep learning either in Pytorch and TensorFlow. But let's look at what happened. Now, Theano, one of the first deep learning from ceased to exist. So Theano is no longer. What about TensorFlow? Consume Keras entirely, and it is first class API. So it means whatsoever you can do with TensorFlow stuff, you can do with Keras, because it is now first class API. More or less where we have objects and object functions, classes. In Python, they are first class object, right? So in Python, all this, everything is first class, right? Function classes. So here also, Keras is now first class API in TensorFlow. And with TensorFlow 7.2.0 with eager mode by default, even though slower than, okay, now TensorFlow released what we call TensorFlow 2.0 with eager mode. Before, TensorFlow was actually using what is called graph mode, or what, yeah. Now eager mode is somehow for, okay, when I put this one, there is more explanation. If you don't know eager mode, when you go there, you can see. So eager mode actually allow you to run your program and see and iterate faster. So for example, in Python, you can write x is equals to 2 plus 3, y equals to 9 plus kaza, and now x plus 2 give you the answer, right? So as you iterate, you see your answer. So that is what we call eager mode, or dynamic, right? Dynamic mode. So it allows you to debug, right? To debug your problem as you see it, what is the problem? Unlike in the graph. So previously in TensorFlow 1.0, it is based on graph, right? You need to build graph, and now after you build the graph, then you run. If you have problem, it's difficult to actually debug. It is difficult to, you know, iterate for research. But TensorFlow is also as adapted to eager mode, and yeah, you will see the detail of that when we come to the chapter. There is also a new framework called JAX or YAX or whatsoever. I don't know how to pronounce it. How do you say this one? Is this YAX or JAX?
I think it should be YAX.
Okay, YAX. All right. So right, YAX. So
let's go with pronounce how you see it. So just
yeah, so it's called YAX. So we now have YAX, which is basically a new deep learning framework by Google as well. TensorFlow is from Google as well, but they developed this independently from TensorFlow and started getting attraction as NumPy equivalent. So this is just like NumPy equivalent of GPU with GPU, autograph, and yeah, with a lot of other stuff. Yeah. So what about Pytorch? What we are using, consume Cafe or whatsoever, replace most low-level Lua-based torch project, added support for NNX, and added delayed execution, that is grab mode. So Pytorch was basically it's not on grab mode. It was based on eager mode, but now they added what is called grab mode runtime, but on touch script, and they released this, but now they are no longer in 1.0, they are in 1.11, I think, Pytorch. Yeah, so this is a lot of history about all this kind of framework. But now I think if you are doing research, Pytorch is one of the top. For example, now if you go to Hugging Face, all the models, I think 70% on model in Hugging Face, you can see them, they are based in Pytorch. Yeah. Right, so that is it. So TensorFlow has robust pipeline to production. One thing that TensorFlow actually is on top of Pytorch is that TensorFlow has robust edge in terms of production. Yeah, in industry, but also Pytorch with the advent of TouchScript and eager mode. Both fighters now are becoming, because TensorFlow now support was basically before on grab mode, now supports dynamic or eager execution. Pytorch was basically support on eager mode, now support also the grab mode. So they are coming together, they support everything. Yeah, so that's basically, you can see that now with advert now with this year from 2021 to now, you can see this red is Pytorch. So Pytorch, this is Google trend. Pytorch is becoming on top of TensorFlow. As I told you, TensorFlow was basically the most widely used deep learning library, but now Pytorch is becoming more and more adopted. And I think in the couple of years, actually, Pytorch will overshadow TensorFlow entirely. Right, so anyone want to add something? Falalu, you want to add something? Or question?
No, sir.
Okay, let's move on. So if there is nothing, so now as you see, this is just the book book. I just copied, so just for this presentation. So the section, this section discuss about how Pytorch support deep learning. So how Pytorch support deep learning? Pytorch is written in Python, but there is a lot of non-Python in it. They have been written for performance reasons. They have been written in C++ and CUDA. What is CUDA? Basically, CUDA is a language as well, like C++, like Python, but it's also faster. It support what we call parallelism. So it was developed by NVIDIA because they have this GPU and now this GPU actually support this CUDA. So Pytorch also was written in C++ and CUDA. However, as you know, a lot of, maybe I think 80% of people using Pytorch, they are using Python, right? So the Python API for Pytorch is where the Pytorch shines, and because a lot of researchers and many people, they are using Pytorch through API, through Python API. So you see, you can actually do Pytorch in C++, and yeah, but what we be using is using Python. Yeah. So now, how Pytorch support deep learning? So one thing we already said is Pytorch support deep learning with creation of tensors, right? So Pytorch provide us with tensor, right? So what is tensor? So tensor is basically just n-dimensional array in Pytorch. Tensor supports some additional enhancement with unique term. So for example, this is a single number is rank 0 tensor. This is a vector, which is rank 1 tensor. This is rank 2 tensor, which is matrix, and 3 tensor, rank 4 tensor. So it basically, a tensor is generalization of an array to n dimension. And basically, Pytorch provide us with this tensor, right? Pytorch provide us with tensor and also operation on this tensor. So for example, given the tensors, you can do multiplication, you can do addition, you can even, of course, it provided with what is called autograph. You can save this calculation on this tensor and try to automatically find the gradient. So let me show you something that why do we need tensor? So this is an example from the book. Why do we even need the tensor in deep learning, right? So one may ask, so if you have a data in deep learning, if you want to use deep learning, this is your data, But before you work on this data, you must change your or represent your data in form that deep learning models can understand. The model, the form that deep learning model can understand is called tensors. You need to represent your data in form of what is called tensors, right? So this is your data, maybe images. So you need to represent the images in form of tensors. This is your data, maybe tweets. You need to represent these tweets in form of what is called tensors, right? So this is the basis of why we need tensor, because this machine, this learning algorithm, you must give them tensors. For example, we all know computer understand only what we call byte, right? It does not understand string, right? So if, for example, I write in my computer, I love this computer, but for computer to understand it, you know, this string is represented as what we call Unicode, right? Right, but it must be converted into the low-level language that the computer can understand. That is byte. So we can use maybe we have ASCII, we have, you know, all those kind of representations that yeah, you know, so computer understand. So for this model, deep learning model, to understand your data, you must represent it in the form it can understand. The form in which data deep learning model can understand your data is in form of tensor. That is just why we need tensor. As your computer can understand bytes or bit, I can say, I don't know, bit, is it bit or byte? I can say anyway. So as your computer can understand bit or byte, then your deep learning model understand only tensors. So that is that. And now Pytorch provide us with these tensors. So this is how Pytorch support deep learning. It provide us with tensor. And yeah, so you can see tensor is generalization of vectors or matrices, and it's easily understood a multi-dimensional array. Tensors are building block of deep learning. So you can see they are building block, and they are the most fundamental data structure in Pytorch, right? So they are most fundamental. So in Pytorch, you cannot work with maybe array, you cannot work with matrix, something like that. I mean, what you want to do is you want to work with tensors. In fact, because tensors are so useful, TensorFlow was named after tensor, right? Because they are so useful in deep learning. TensorFlow is deep learning framework, so that's how it was named as TensorFlow. So we understand this is actually why tensor. So anyone want to add something here? Your question? Falalu, you want to add something or want to say something?
No, sir.
Okay, so I think, what about Tunde? You want to add something? Brian, Umar, Amina.
Dr. Shams, I want to say something.
Okay.
I don't know, when we are talking about, or when we are dealing with text, how are those texts represented using the tensor you are talking about?
Right. This is a good question. So this is what we will see. Yeah, I think I have something will come. So every data type is represented in tensor differently. So for example, if we are talking about data text, I think it's normally represented in you can see rank 2 tensor. We'll see that if it is image, it is rank 3 tensor. If it is video, it's rank 4 tensor. We have different kind of tensor representation depending on your kind of data type you have. And I think the next chapter, chapter 2 or chapter 3, discuss thoroughly about how the different data is represented using tensor, but I will touch some a little bit about that. Yeah, so text also, you have text, tweet, or whatsoever, you need to convert them into tensors, and we'll see how that works. Yeah. So let's move on to this. Python support deep learning autograd. So another thing is support for autograd and distributed computing. The core Python, the second core thing Python provides is the ability tensor to keep track of operation performed on them and analytically compute derivative on an output of a computation with respect to input. So you can see here, when we have an input of our data, whether it's text, whether this is layered representation. These representations, they are mathematical functions, but mathematical functions, we perform operation using tensors, right? So we perform tensors whatsoever, and we make prediction. This is our target. We use a loss function and we find the loss score. And now these are optimizers. But for us to update this weight, trying to find where we move from the direction, we need to do what is called back propagation. But one thing, this is now maybe a little bit stopped, but I think we'll discuss this in detail, back propagation. But the key idea here is that Python provides the ability of tensor to keep track of operation performed on them. So any operation performed on this layer, on tensors, any operation performed on this, Pytorch provide an ability, what is called, that keep tracks of this operation so that you can do what is called back propagate, trying to find the loss function, how to update your weight. So Pytorch keep track of these operations. I think the detail will be discussed in the later chapter. This is used for numerical optimization and is provided by natively tensors batch of this batch. Okay, so in Pytorch, this is provided what is called autograd, right? So in Pytorch, this kind of storing this operation on them is provided by autograd, and the detail of this we discussed is not in this chapter how this works. This is just chapter is about introduction of this concept, and the details will be discussed later. So you can see Pytorch autograd abstract the complicated mathematics and help us magically calculate the gradient of high dimensional curve. So you can see that because these are mathematical functions, and all mathematical functions, if they are derivative, they are differentiable. It means we theoretically, if a function is differentiable, you can find its minimum, right? Minima, right? So for example, we have our input and we have our functions here. We try to predict, and it turns out that the loss score is higher, right? It's high, and we want to actually find the derivative, the minima, find the derivative of this function because they are differentiable. We can actually find their derivative and propagate to try to move close to the minima, right? And so Pytorch autograph provide this stuff. So we discuss this kind of derivative maybe in the later chapter, but this is just touching the scratch. So yeah, so another thing you can see is torch.nn. So this is what I'm saying is Pytorch provide us with this torch.nn. We don't need to implement everything from scratch, all this layer. So for example, this is your input layer. So you can say torch.nn linear. You know, you have to input and the output are 2. You can see this step, you have what you call sigmoid. You can implement it here. You know, you have maybe linear, another linear layer here. You can put it, and you have the last one, sigmoid function. So you can see in Pytorch, you are providing all this layer representation. Maybe this is just high level implementation, just to show us a sample of how Pytorch implement all this this layer, and this loss function, which is sigmoid, something like that, to find the true function. So this layer, you can see is represented maybe here linear, you know, linear layer, and the last one here where you can find the score, you know, loss function. You can see this is, you can find the loss function using sigmoid, you know. So all these, you can see this representation of deep learning as we see it here is represented using, maybe you can see is in torch.nn, right? So this is just an example on how this module support our deep learning, right? So here what is said, the core Pytorch module for building neural network are located in torch.nn, which provide common neural network layers and other architecture, fully connected layers, convolution layer, activation function, loss function. So you can see torch.nn provide the loss function, provide layers, activation function. So here you can see you have activation, everything. So this is one thing Pytorch support deep learning. Patching the data. So how deep learning support, how deep learning support our stuff. Another thing is deep learning support fetching the data, right? So fetching data, because if you look at this one here, we have our data, right? Deep learning, we need to fetch some data, right? And now fetching the data is, we need to fetch the data. Now you can see here we have the data. This is a single data, but the single data we are divided into different tensors, right? 1, 2, 3. This is many tensors, right? We have a data. Unlike machine learning, in traditional machine learning, what we do basically is this: we give our machine learning algorithm our data set, right? And we try to do machine learning with that data. But in deep learning, you don't work on that. You don't just give like your machine learning your complete data, your deep learning algorithm your complete data. No, what we do in deep learning, we divide our data set into what we call batches. So if I have like 1 million, so I divide my data into somehow batches, right? Can you see dot means many batches? Now my deep learning algorithm, now where it comes, it will not work on the complete data set. It will work in one batch, try to find, run every step here. Run where it is, every step here. Can you see this? Every step deep learning algorithm will work on this single batch. Now try to adjust the weight and, you know, make the prediction better. Now that is called one loop, training loop. It will take, it will take the next batch, it will take the next second batch. So deep learning basically work on batches, not yeah, one can say you can work on single batch, but ideally, practically, we deep learning we work on batch. So now deep learning, so Pytorch support again patching data. We need to convert each sample from our data into something Pytorch can actually handle tensor. So Pytorch provide us with something that we can actually fetch our data, to fetch your data, to transform it into tensor. Pytorch provide us with functionality. You don't need to implement. So from here, from your data, whether it's text, whether it is image, from here to batches, Pytorch provide us with that stuff to do that. So what is that? So you can see the bridge between our custom data, whatever custom data, maybe it is image, it is text, it's video, and a standardized Pytorch tensor is data set class. Pytorch provide this. So Pytorch provide this in discussed in chapter 4. So Pytorch, it means it provides us a class, something that can actually help us to import our data and now divide it into what we call batches, right? So it is implemented in that data class, and we see. So as this process is widely different from one program to the next. So this process is different from one program to the next. We'll have to implement this data using ourselves. So this is an example I talk about. So if you are using vector data, we have different kind of data represented. So if you are using, for example, time series data, you can have what we call your rank 3 tensors. If you are using image data, you can have rank 4 tensors. If you have video tensor, you can have rank 5 tensors. So if, for example, vector data, so for example, for text, we can have our samples, we can have our features. So this is rank 2 data. We'll see, I don't want to discuss this detail, but when we come to the chapter that discusses about tensor, we'll discuss. But ideally, the tech point here is that each data we have, if it is image, if it is text, if it is video, it is represented in tensors differently. That is the main idea. But at high level, if it is time series data where we have time stub, so we can have sample, time stub, and features. If it is image data, we for image, we have the channels, and we can have height and width. We have the samples. So if you have 1 million images, we have the sample is 1 million, and each one it has the height and width. And images have channels, like some stuff like that. If it is video, we have each video has a frame. And it has a frame, then we have height and width and channels and sample. So you can see it's rank 5. So this is a basic idea, but I think for text data we'll be using so this will be details in the next chapter. And the next one is data batches. So you see here, as I made mention, we took data in different batches. We don't work with a single batch, right? So as data storage is open source, we want to parallelize data loading. However, Python does not provide easy, efficient parallel process. We need multiple processes to load our data. So we have what is called data loader as well, that we actually discuss about that in chapter 7. Data loader actually load our data in parallel processing. The training step. So this is the training step in deep learning, which is basically several steps. So what this means is, this is what I explained. So this is what we mean. Now, you have different tensors, right? Batches of your data. So this is your data set. Now this data is divided into different sample tensors, tensor n, Now for you to do the training, you take one tensor here. And now when you take this one tensor, you need to follow this step. Input it into the your machine learning, right? Into your machine learning, all this, find the prediction, find the true level, calculate the loss function, use the loss function to calculate the score. And now if the score is higher, try to back propagate, try to change the weights to optimize the weight, and maybe the learner rate, trying to update the your stuff until the score is low. This each frame, each batch, you repeat this process in each batch until your loss is low. So each batch, so for complete one, for complete all this is called what we call training loop. For complete batch, if you have your batches for complete, is what we call training loop. Yeah. So but for each batch, when we go through it, it's called iteration. So if I finish with one batch, it means I finish one iteration. If I finish second batch, 2 iteration. For complete one is called batch, complete one batch. So what we mean by this is, so This is also provided, I think, in Touch. It's in the channel we evaluate our model. So you can see at each step we evaluate our model on the samples we got from the data loader. So data loader give us a sample, and we give this one sample to our deep learning algorithm here. And what we do, we then compare the output of our model to the desired output. So when we finish everything with the model, we compare the prediction with the true target. So this is the true target. This is the prediction. We compare the true target using the loss function. If the loss score is higher, maybe 0.8 or something like that, then we need to adjust the weights here, update the weight using optimizers, and now go on along until our loss score is so low. Yeah, so Pytorch also has variety of loss functions at our disposal. So we have many loss functions, we see them. So loss function depend on your problem, and we have Pytorch provide with that a lot. Right, so after we compare actual output, yeah, so this is basically what I explained. Yeah, so we have many kind of optimizers. Optimizer implementing what we call gradient, many algorithms that can be used. We have what we call gradient descent, mini batch algorithm, gradient momentum, diagram. So a lot of other stuff have been implemented on these optimizers. We will see details when we come. Yeah, and gradient descent is one of the most basic use optimization algorithms. So the optimization here we have, this is an algorithm will try to optimize to find. So for example, now we do prediction, this, and now that we work with the loss function, we find the loss score. We said, okay, this loss score is higher. Now, how can we actually change our weight so that the next iteration, our loss score decreases? So this is a function of optimizer. It is the one that determines how we change and the direction we move in our gradient, right? So this is the function. The detail I think will be discussed, but this is the high level, yeah. Parallel training. So still we have what is called parallel training, right? Because the deep learning, maybe you have large number of data, you cannot do them on one single machine. Sometimes we do what is called distributed training on multiple GPUs, right? So this one, again, TensorFlow provided with what we call provided with what is a module called toasted distributed, toasted and then parallel distributed, and that actually will employ us to run our deep learning on parallel framework. So instead, for example, to work on a single computer on single GPU, you can run all these batches. You can see you have one batch, n batch. So if you have 1 million batches, you have parallel you can run each batch in this 1 million stuff. So this will execute, reduce the timing. Yeah, so deep learning Pytorch provided with that support. Again, train model. So when you finish everything, you train everything, then you will have what is called train model. So this is the train model. So when we finish our training, everything, at the end, what you will have is what we call train model. If we finish our training. So what is train model? So train model is the most time consuming part of deep learning training loop. This is the most time consuming. It will take days, months if you are training from scratch. Yeah, I mean, it takes a long to do that. At the end of it, we are rewarded with a model whose parameters have been optimized to our work. That is train model. So this is a train model, what it contains. So you can see here, as I kept saying, we have what we kept changing parameters, right, of the model, weights and stuff like that, way to see that these functions. So at the end, when you have your model, you will have optimized parameters that gives you the loss function, which is very low. So this is a train model with optimized that can make a good prediction, and that is called train model. So we can see that your sales data, the Pytorch provide us with a way to actually transform our data into what is called tensors, because our deep learning algorithm cannot learn anything like image. It needs to be transformed to tensors. So now we have also what we call data loader that will load the tensor into our training loop. We have what we call, you can do parallel distributed training, and finally you can also do this will actually give this is on train model, it give you the train model. And this section is actually, because you can see the loop, this is the part that takes long time. You just continue doing it. Yeah, you can deploy the model actually after. So you can deploy your model Touch script, using Touch script and via cloud, to do on our mobile phone. So for example, in your mobile phone now, when you're trying to type something, you can see if you write good, it's trying to predict all those stuff by deep learning, and they have been the cloud, trying to do that so that they can fit into your mobile. So here the train model is not something that can be actually your mobile phone. There are a lot of other techniques that you can trim down all the large and stuff like that to work on our devices. So yeah, so that is that. For this chapter or for this book, first part, as we said, the first part you can use your computer using CPU, but the second part actually requires a GPU enabled device, right? But you can use CPU, but it takes you forever. But there is Colab. Maybe Idris will give us maybe in the next session on using a Colab, so that we can actually, all of us will understand how to use Colab very well. So one of us, maybe in the next session, we can, yeah. So Colab provides you with pre-GPU that you can run your models, and you don't need to do that. But if you want to actually train your models and some stuff, you need better than Colab, because Colab has some limitation in it. It's not like something that you can use. Yeah, it has limitation. That is it. Yeah, so you can also use train your model in multiple GPUs or clusters as well. Also, part 2 has I don't know why part 2 has like 60 gig of data, and it one on compressed 120. So this is large. So part 2 has a lot of project, which is end-to-end, trying to do deep learning end-to-end from transforming your data to tensors and a lot of other stuff. But we'll see how it goes. So that is the end of chapter 1. And yeah, so anyone want to add something?
So I wanted to ask with regard to the batch training. So I think we said given a batch, the training loops execute before going to the next batch. So the training loop, does it execute only once per batch, or does it execute multiple times on a single batch before going to the next batch?
Okay. So you know, we provide yeah, while we are doing deep learning, right, we actually we provide what we call this number
Pytorch.
epoch. Yeah, epoch. Yeah. So if we have this is a badge, right? So when we have this one badge, these badges, maybe 1, 2, 3, right? So the first one here is single iteration, right? Single iteration, single iteration. Now, if we go through all this one, then we have what is called one epoch, right? Now, in deep learning, to learn, this is some theoretical part, but this is just a scratch. We provide a number of epoch we want to train our model. So training one loop. Okay, one complete training loop is called one epoch. So in complete training loop, we have n number of batches. Now, if I have 1 million batches, now I train each iteration completely. That is one epoch. So if I have 10 epoch, it means each batch will be trained 10. I don't know if it is correct or not. It is. Can you talk?
Yeah, I think that's it.
Right.
One single epoch means passing through all the batches of the data completes one epoch. So going for the second, it starts from the first batch to the last, so until it finishes the number of specified epochs.
Right. Yeah. So yeah. So this cycle training is what we call epoch. One training loop. One complete training loop is called epoch. And we can specify the number of epoch we want to train our model. And this also, we can see it details in our sessions to come. Yeah, so again, anyone wants that, feel free, please. This is a forum that we want to feel ourselves like free. It's not something, you know, that feel free to ask questions. This is where we learn. You can see somebody is giving an input, you know, so feel free to, so ask question and contribute. Ibrahim, you want to talk?
No, everything looks good.
Okay. Umar, want to talk?
Yeah, I just feel since it's an introduction class, more question will come subsequently. Like this is just a general overview. And it's kind of abstract for now, but I guess as we get our hands dirty, more questions will come definitely.
So this is basically the general overview of how you can see this is I talk about the whole deep learning without even looking at the code, you know. So this is just like overview of the chapter. I encourage you also to read this first chapter. It's really to get. So when we come, I think if you don't understand, that's fine. As we go, we will actually make it clear every step. We would start from the beginning, hands-on, how we can do this, how we can do this, how we can do this, how we can do training, you know. We can start from the beginning to the end-to-end deep learning, right? So any question? Also, as I said in the beginning, for those that just join us, I said we try to create, this is different from our normal weekly sessions and bi-weekly session where we intend to bring this as a way in which actually we can strengthen collaboration among us, so that we can understand and also to serve as accountability partners. So for example, one want to read something but he may not read, and somebody has maybe he's not good in programming, or he has liking some mathematical concept, we can complement each other, right? When we understand, when we try to understand. And also we said that each chapter is shared by volunteers. So if you are okay, that is not mandatory. It's volunteer. You can say, okay, I want to read. So for example, chapter 2, Ibrahim want to present. Chapter 3, Idris say we want to present. Chapter 4, Tunde want to present. So if you are comfortable, not now, maybe you just go and read and say, okay, yeah, I can present. If you are not comfortable, and also as you can see, it's not like for me that I do the presentation today. It's not like I know everything. We just complement one another by putting some input. So so this is volunteering. So you can say, okay, I want to present this. So no one is expert here. All of us, we are just learning. So it's not also like teaching. So I'm not teaching you here. So we are just discussion. This is just a discussion forum where we can do And as I said, I will push. I have a GitHub repository. I create a GitHub repository. I will push this one. So each chapter will put in the GitHub repository. We will also have the recordings. So for other people that may not have come, we will share the recordings so that they can have access to that. And also we, as I said, because not everyone is interested in our maybe this study group for Pytorch for deep learning, we will go back to Slack channel. We have our Slack channel for Hausa NLP, so we'll create like Hausa our deep learning with NLP study group. And now everyone, if you read something and you don't understand, please ask question. So we don't want spam people here in the Slack, in the WhatsApp. So we'll go there. If you have question, you read something, ask question. We iterate, we learn from there. And the main idea, as we said, is we will start with this book, Pytorch for deep learning. And the moment we get good understanding of Python, then we will move on into more NLP niche area for deep learning. Because as I said, now deep learning, NLP and deep learning, they are Pytorch. Many people, everything is Pytorch. People for research is Pytorch. That is why we select this book and get the understanding of Pytorch. And now we will select another book or another stop to move on to our understanding into more NLP related areas. And now there we'll find more collaboration and more stuff. So one thing also we should know, every week we will do 2 chapters. Now tomorrow Ibrahim will present the next chapter, but we also need to understand, some people like Umar said that 8:30 is too early. So what do you think a good time for us to actually start doing these sessions? We thought like 8:30 to 9:30. Of course now it's more than 30, but we started late. What do you think, people? What do you think? Let's discuss now. Do you think 8:30 to 9:30 is good enough? What do you think? Before we were thinking to do Friday and Saturday. But what do you think? Is it okay, like Saturday and Sunday, 8:30 to 9:30? We wake up early morning and just finish. We go to our businesses in the day business. What do you think? Umar, is it you that you say maybe it's not okay?
Yeah, I'm looking at it's like it's weekend, it's way too early. But I don't know if the rest, if 8:30 is fine, I can manage, because I believe it's gonna be like a hectic weekdays, Monday to Friday. Saturday we might wake up a bit late just to re-energize our body. But then 8:30.
Yeah, okay, Tunde. Yeah. Okay. Tunde, want to talk? You raise your hand. Tunde, what do you say? What do you want to say?
Just like you just said now, I think it's something we can just do early and then move on to what we'll have for the day. For those of us that are sports conscious, like fitness conscious, we can do our exercises as early as probably 6 to 7 o'clock.
Exactly.
Take our bath, then by 8:30 to 9:30, while having breakfast, we can be having this discussion. And by 9:30, then we are ready to either go on to the activity for the day, sleep a little, or do whatever we want. I think if we leave it to like a later time, some of us will get ourselves occupied with something else. And I don't even know how evenings, a lot of people like to chill and relax in the evenings with their families, take children out and all of those things. So somebody that suggested us bringing it down from 9:30 to 8:30, I think 8:30 is fair. I don't know other people's opinion.
Right. Tunde, you say 8:30 or 9:30. Which one do you say? 8:30 or 9:30?
8:30 is
okay. Okay. Yeah. So yeah. Right. So we will decide maybe in the Slack so that now we are taking people's more time. But please, we can decide. I think tomorrow, we will have the 8:30 maybe in the Slack. I will share the Slack channel so that we can move on there and keep discussion there. We can even do a poll if you want. But yeah, the main idea is for us to actually get excited and learn together. I believe in learning together. This is one best way because many good heads are better than one, right? Maybe I can understand something in a different way, or look at us now. We are how many? 10 of us. We can understand something differently, and we can contribute to one another, and we can complement our understanding, right? And also one thing I will encourage, like as I said, this is volunteering. The more you volunteer, you say you want to present a chapter, the more, if you go and read, the more you understand it better. So if you are comfortable, please choose a chapter. Say, I will lead the session. You can see today I lead the session. It's not like I teach members. It's just like I facilitate the session, right? Facilitate. I teach you facilitate the session.
Facilitate.
Yeah. So yeah. So now, as I will repeat, Ibrahim said he wants to present chapter 2. Idris will present chapter 3, and Tunde will present chapter 3. So we can move on along. And so also I shared here. I shared, I think let me share something. Oh, okay. Also, I haven't discussed about the installation of Pytorch, right? So, for example, now we can come to this website, which is where we have the Pytorch. Let me share it. So for those people that haven't actually had the Python installed already, so we can come to here. So you select your OS Pytorch build. So we have stable version. So just install stable. We have nightly. So this is nightly. It's like latest update, but it may not be stable. It may have some issues. But install stable. Select your OS, Windows, package manager. They recommend Conda. So just create Conda environment. I think they open say here, whatsoever you use. Anyway, this is not something whether Conda or PIP whatsoever you use, but I use Conda. Select the language. If you are using compute GPU, you can see I select Windows. You can set CPU if you have your computer, but if you have GPU, you can select that. And now basically run this command. You can see that. Yes. So this is how we can install actually the Pytorch. So there are a lot of other explanation here, but there are prerequisite. You need to have your Python install, and you need to have your PIP or Anaconda install, all those stuff. So you can look at the verify, or if you are it's installed, you can see import torch. For example, here, I can come here because I already installed Torch, and you can see here, my kernel is deep learning Pytorch. So you can see just starting now. If you run this after your installation now, if you do this, you can see actually you will have the correct output. Then it means it will show you that you install Pytorch successfully. So you see this kind of output. So as I said, I already pushed my chapter 1 here. So you can see chapter 1 here, I already push it. And so you can actually, I can share this one. If you want to present your chapter, you can prepare it and share and you can push your, so that, yeah, also we can put recordings. Yeah, unfortunately, the book also has its own Jupyter. So you can see, unfortunately, chapter 1 doesn't have Jupyter. I just put up the explanation myself, but each chapter 2, 3, up to chapter N, they have their Jupyter. So you can just clone the chapter. You don't need to create the chapter from scratch. And so you can actually argument with the existing stuff, right? Yeah, so this is something from the book, like if you want to do see how this GPT works, for example, one may say, okay, this deep learning, I can clear this guy. I say, okay, Nigerian corrupt. Let me see something. So you can generate text. You can see this guy is generating text automatically for you. This is deep learning, right? And GPT, right? So you can see. Just given like prompt, it will generate text automatically for you. So this is the power of deep learning, right? There is no feature engine and stuff like that. You just give it some prompt and you can see it generating a news for you automatically. This is really powerful. This is what we'll be building now. At the end of the day, when we'll be building this stuff. And also I would like to say that we have what is called where we will be putting our learner resources. Let me quickly share that. Just excuse me. Notion. I share a Notion, right?
For the notes, yeah.
Yeah. Okay. Let me open the Notion and then we can go on explain something in it. Okay. Not this one. And not this one. Just give me a second, please. Okay, let me open my Notion. So basically, in our Notion page, we will be like recording all our activities. This guy is not opening. I don't know why. Give me a second. Among us who had an experience previously with Pytorch, who had previous experience with Pytorch?
Maybe Idris, I used TensorFlow.
Okay, you use TensorFlow, right? Tunde, I know you had experience with Pytorch. Idris also had experience with Pytorch. Who else? Experience with Pytorch. Okay. Right. So this is where we will be like storing our meetings. So weekly meetings here. You can see my browser, right?
Yeah.
This is our weekly meeting. So here, our last meeting here, we can see we put the agenda and also, even if you don't attend the meeting, you can basically come and see what we discuss in our meetings that we do bi-weekly. Not this one. And this is our book club. So in each book club chapter presentations, Ibrahim, Idris, other people. And now we put the recording. If you don't attend that session, we can put the recording here and you can grab, you can actually get the. And now this is our weekly presentation. You can see here, this is my presentation. We can start putting the GitHub repository where we can put our presentation now. Amina will do our presentation next week on how subordinate or something like that. Idris will do the next one on genome data set that we work. Our work that has been accepted in LREC. So this is this one. Yeah, so this is some kind of ideas. If anybody has some ideas to discuss, we can put here and come back And this is a project, so many people may be working on the project. We can put the project that we are working on. So this we will update this one. I can add people so that people will actually help to do that. So this is basically yeah, this is will be accessible to any of us. I share it. So yeah, so this is what I have for today. We are almost so for today, because it is like the introduction, we have a lot to say. We're actually running out of time, but sorry for going over the time. Yeah, so any question or any contribution that will make this study session better, yeah, is welcome.
I think that if the section is interactive, that will be much understandable. So since we all have the book, maybe before the next class, if we can kind of read through, and if there's any challenge, then I mean the class can be more interactive, where we can ask several questions and things that are not clear, maybe from our readings.
Yes, exactly.
So that's the idea.
Exactly, that's a good. So that's the purpose. I mean, let me tell you, if you are coming to this session and you don't read the book, believe me, you will be deceiving yourself. So one thing is that we all read and we come with our question, but if you don't read, I mean, you will be lag behind. Yeah. So the main idea is for us, like as I said, accountability partner, to have some people to hold ourselves accountable. Right. Next week we'll do chapter. You know, next week you are going to do this. Then you okay, you need to read also. But yeah, and you will understand, ask more questions. Yeah. So we share the book, and yeah, you can read it, and you ask more questions.
Actually, I have another suggestion here.
Yes.
Which relates to asking question asking. During the presentation, when you are presenting, you after every juncture you ask if there's question. I think that's a very good idea. But from people asking the question, I think it will be better if we try to restrict the question during presentation to only what is being presented. Then after the presentation, every other question can come, we can brainstorm. But during the actual presentation, the question should be restricted to the chapter being presented. Then after that presentation, the question can come from anywhere, and anybody with idea can chip in.
Okay, I understand what Ibrahim is saying. Like, for example, if you are asking about, you are presenting tensor, how to do multiplication, so the questions should relate to that thing. But yeah, so this is a good idea. But also sometimes you can see the question linked to something, you know, because this thing are interwoven, right? Some, you know, something that is not directly related